Hello and welcome back to another video. In this problem we're going to be working on find the difference. And it's a pretty straightforward one. Essentially you are given two strings s and t is generated by shuffling s and then adding one more letter at a random position. So in this example they have a, b, c, d and they add an e, but essentially what they're saying is these letters can be shuffled, so you can't just like go through them and find the first letter that is different, because you can have something like A, B, C, D, shuffle all the letters, right? Get something like B, C, A, D, and then put an E in some random spot. So you can't just like go letter by letter. That doesn't work. And there are two easy approaches for this one. One is kind of hard to come up with, I guess, and one is really straightforward. So for the first one, what we're going to actually do is we're going to actually just get all the letter counts in S. And so let's say we have A, B, C, D, for example. For S, it would be like A1, B2, C, or it would be not B2, B1, C1, D1, right? Then you do the same thing for T. So T is A, B, C, D, E. So you'd get A1, B1, C1, D1, E1. Essentially do that, and then you just go through every single key in T, and whenever there's a difference, you just return that one. And the reason you want to go through the keys in T is because there might be a letter in T that's not in S. So if you went through all the keys in S instead and look for a difference, you would never find E, so then you would say all the keys are the same and there's nothing here. So you just go through all the keys in T and you look for your first difference. So like you'd go through all the keys, it'd be like same, 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 same. Oh look, this one does not exist in S. And then as soon as you get one that's different or a value is different, you just return that. So that is pretty straightforward, and luckily enough in Python, it's super easy to do, and let's code that solution out. So essentially, it's really straightforward. All you do is you just say like count s equals counter, and what a counter does is it manually gives you the count of every letter. You could also, if like you had a question and you weren't allowed to use a counter, this would be also pretty easy to code up, right? You just go through the string and you add up every single letter. You keep increasing the count in a dictionary. But a counter does that for you, so you can have count t equals counter of t as well. And then you just go through all of the keys in count t. So to go through all of the keys, because this is a dictionary, you want to go through the keys. You just say for key in count t keys, if count s key does not equal count t key. And by the way, so let's say this key exists in this dictionary but doesn't exist in this one. So normally when you try to look up a key that doesn't exist in the dictionary, you get an error, but this counter is a default dict, I believe. So if it doesn't exist, it will just give you a default 0 value, so it's fine. You're never going to get like an error. So essentially, you just look for a difference, and you just return the first key that is a difference, and we can try that. Pretty straightforward one, for sure. And you can see it's very efficient. And we can even do the time and the space for this one. And the nice thing that I would recommend for doing these is, while you do have to look through both your strings, right? So essentially S and T, it's basically going to be, the time is going to be like O of S or O of T, because they're basically the same length plus a character, right? And then you go through all the keys. But the nice thing is, since there are only 26 keys, it's only lowercase letters, the space for this counter is actually of 1. I talked about this a lot in my other problems. Because there are only 26 key max, right? Like this can be a million, a billion characters, and there's only 26 keys. So regardless, the space for the counter is actually O of 1. So it's an O of 1 space solution. And this is also O of 1 time, because essentially there's only 26 keys. So that's one of the ways to do it. Pretty straightforward. And like I said, if you don't want to use a counter, you can just manually go through your string and check every character and increase the value in your dictionary for each one and do the same exact thing without using a counter. So that's one way to do it. Now let's look at the second way of doing it. And this one's a little bit trickier. So let's say we have this ABCD. Actually, before we do that, so there is another problem that I think it's something like find the only unique number in a list of numbers, right? So you have a problem like this. Let's say you have some array of like 1, 2, 3, 4, 1, 2, 3, 4. Actually, let's draw this a little bit better and make it cleaner. So we have 1, 2, 3, 4, 1, 2, 3, 4, and let's say we have some unique number like 8. And it asks, find a unique number in here. So the way you can actually do this is bitwise XOR, because essentially two numbers bitwise XORed with each other actually give you 0. And it doesn't really matter the order you do this in. So let's just try, yeah, I guess we can even try to go through this and kind of show you. So we can even go through this whole example in bitwise XOR. So essentially we're going to bitwise XOR all the numbers and see what we get, right? So we first have 0, right? We started out with 0, and then we had 1. So 0 bitwise XOR with 1 is just 1. Now we have 1. Then we get 2. So 1 with bitwise XOR of 2 is 1, 1, right? And then this bitwise XORed with 3 is, so 3 is this, is 0. Now that bitwise XORed with 4, so 4 is this, is this. Now that bitwise XORed with 1 is 1, 0, 1. Then with 2 is 1, 1, 1. Then with 3 is 1, 0, 0. Then with 4 is 0, 0, 0. Right? Remember, so if you are confused a little bit how I do this, remember for a bitwise XOR, 0 with 0 equals 0, 1 with 0 equals 1, 0 with 1 equals 1, and 1 with 1 equals 0. This is the calculation that I'm doing. Essentially, you just look number by number. So now we have this. We went through 1, 2, 3, 4, 1, 2, 3, 4, and then finally we add the 8. So 8 is this. So that bitwise XORed would be this right here, right? And this actually gives you 8. So this equals 8. So you can see how when we bitwise XOR every number, that's like a trick that you can know is if you're looking for a unique number in a big list and it's only duplicates, you can just bitwise XOR the whole thing, and then you will guaranteed get the unique number. And so we can use that approach with the letters as well. So if we take a look, let's say we have our word, right? A, B, C, D, and then we have A, B, C, D again, right? We're going to have all repeated letters, and then there will be one more unique letter. So essentially, we could take this bitwise XOR approach, but how do we XOR letters? Well, that's also pretty straightforward. You can just convert the letter to the ASCII value for the letter. And so in Python, if you do ORD on the letter, it will give you a number that's the ASCII value for the letter. And I don't remember the exact ASCII value for each letter, but it doesn't matter. Essentially, ORD for A will always give you the same number, and that's really all that we care about. You can look up ASCII values for the alphabet if you want to as well. But essentially, every time you do ORD A, it will always give you the same number. It's like 200 or, I don't remember, maybe it's not. But anyway, it'll always give you some number. Let's say that number is 20. When you do it again, it will give you the same thing. So essentially, this will transform things into numbers, and these two numbers will always be the same. 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 So essentially, when you bitwise XOR this whole thing, this will also give you 0, and then you're going to get the number for this letter. So whenever you bitwise XOR, you just go through the first string and the second string, you're going to have the ASCII value for that unique character that you added, right? Whatever you added. Either you added a new one or you made a copy of one. Like let's say this was ABCDA instead of E, then you would get the ASCII value for A. Like whatever there's the single letter of, which is all we care about, we'd get the ASCII value for. And that's what we're trying to find, right? We're trying to find that extra letter. And so when we bitwise XOR this whole thing, right? So we bitwise XOR S and then T, all like go through every character, bitwise XOR it all. Then we're going to have the ASCII value for our answer. Let's call that the res. Then all we have to do is just figure out like what is that, what character does that correspond to? And in Python, if you use CHR of an ASCII value, that gives you a character. So essentially, you just convert your character into an ASCII value, you XOR them all, then you get the ASCII value for your result, and you just turn that into a character, and that is your result. And it's pretty straightforward, as long as you know, like I said, this trick of anytime you bitwise XOR a bunch of numbers, anytime there's a pair of them, they XOR to 0, and the order doesn't matter. You can do this in whatever order you want. It's always going to be 0. So you can have, you can have an E here, and then this will still give you the ASCII value for E at the end. Okay, so now we can code up that solution. And we will just comment out this. So we're going to make our result equal 0, and we're going to say for every single letter in S, let's bitwise XOR that letter with our result. So res bitwise XOR. So this is just XOR equals. It's the same thing as writing res like this. So this is bitwise XOR, and you want to get the ORD value, right? You want to get the actual numeric value. So you do this. Then you do the same thing for every letter in T. You bitwise XOR that as well. letter. And then finally, our result is going to be now the ASCII value for our answer. So we simply need to turn that back into a character by doing CHR. And you can give this an ASCII value and you will return it. So let's try that. And you can see this works too. And these are both pretty efficient. Obviously, this one technically is more efficient because we're not taking up any space at all. Although this is not, I believe this is not exactly O of 1, but it rounds to O of 1. So the time and space for this solution would be, if you think about it, this would also be O of S because S and T are basically the same length, so it'd be like O of 2S, you know, pretty much the same thing. And then the space would also be O of 1 for this one. But yeah, this one's definitely trickier to come up with, especially if you don't know this bitwise XOR trick that two numbers bitwise XOR that are the same will give you 0, and it doesn't really matter the order you bitwise XOR a bunch of stuff. But that is the second solution. I think this one's super intuitive if you know a counter in Python, or if you don't know a counter, you can just make a dictionary and make it yourself. But this is why coding in like Python is better than, you know, coding in most languages for these problems, because there's a lot of really efficient things you can use. But yeah, this is going to be it for this problem. So hopefully you liked it. Quite an easy one. And if you did like it, please like the video and subscribe to the channel. And I'll see you in the next one. Thanks for watching.